Hi everyone, welcome to Irfan CFPS YouTube channel. In this comprehensive video, I am going to explain how to design a wet sprinkler system for a hospital. By the end of this tutorial, you will feel confident in your ability to design sprinkler systems for any commercial building. I will provide detailed steps based on my experience, ensuring you won't regret investing your time in watching this. After completing this video, you will likely have learned everything you need to know about sprinkler system design. If you find this video helpful, please like, share and subscribe, and also leave a comment below. I would love to hear your thoughts and answer any questions you may have. So let's start. Before we start our design, the first step will be to review architectural drawings, overall floor plans, and cross-sectional drawings. While reviewing these drawings, we need to verify the building size, intended use, occupancy type, and occupancy hazard classification. So in our case, our hospital building consists of a basement, ground floor, and 10 additional floors. You can view the architectural plan on the screen. It's essential for us to thoroughly analyze the architectural plan and understand how this building will be used in order to determine the hazard classification before we move forward with the design part. So this is the location of pump room. Next, it's vital to adhere to local building codes and nfpa standards before designing the sprinkler system. These codes ensure legal compliance and safety. Let us have a look at the key components of the sprinkler system. We will consider black steel ERW Schedule 40 pipe for our above ground piping network. Other piping types can be used as per nfpa 13. For the fittings, we will use malleable iron threaded fittings for sizes 1 inch to 2 inch, and for above 2 inch we consider ductile iron grooved fittings. Hangers and supports. We will use ULFM approved swivel hangers for sizes up to 2 inch, and for above 2 inch we use clevis hangers. Channel supports and riser supports will also be considered as applicable in our project. For zone control valve assembly, basically it covers various components such as indicating type control valve, flow switch, tamper switch, test and drain valve, and pressure gauge. Sometimes we use check valve as well. So in this building, we do consider swing check valve in zone control valve assembly. The ZCV assembly, also known as floor control valve, will be installed on each floor where the pipe enters. Fire department connection. We consider two-way inlet 65 mm size for fire department connection with cap and chain. This will provide an auxiliary water supply to the sprinkler system. Alarm check valve assembly. This covers OS&Y gate valve with tamper switch, alarm check valve, bell, retard chamber, pressure switch, flow switch, and pressure gauges. Control valves. These are used to control the water flow. They can be gate valve or butterfly valve. Check valve. They are non-return valves used to prevent backflow in the system. Inspector test connection. A test connection must be provided to test each water flow device for each system. The discharge should be at a point where it can be readily observed. Sprinklers. We use upright sprinklers where there is no false ceiling and pendant sprinklers where there is false ceiling. Landing valves. These are 2.5 inch hose connections installed in staircase areas. In this project, we shall use separate riser for landing valves. Fire hose cabinets. The type of fire hose cabinet will be based on project specification requirements. However, in this project, we consider surface mounted type for basement areas, and for the office area from above ground we use recessed mounted type. Fire extinguishers. They will be placed in accordance with nfpa 10 requirements. Our main focus today is on designing the sprinkler system according to nfpa 13 guidelines. Now I will explain you how to create a layout for the sprinkler system, taking into account factors such as sprinkler spacing, coverage area and pipe routing. Follow my steps and you will find it easy to smoothly design for your projects. Steps to be followed. Number 1. Identify the pump room location. Number 2. Divide the building area into zones. Number 3. Finalize the riser locations. Number 4. Prepare riser schematic diagram. Number 5. Perform hydraulic calculations. Number 6. Place the sprinklers on the complete layout. Number 7. Draw the routing of main pipe and loop. Number 8. Draw the routing of branch pipes and mention the sizes. Number 9. Draw the routing from the pump room to the building to be protected. Here is the pump room, making our first step is complete. Next, we will divide the building area into zones based on hazard classification. As you can see the zoning layout on your screen, here you can find density and coverage area mentioned for light hazard occupancy, and also please note, based on number of zones, the risers has to be considered. For example, for light and ordinary hazard, maximum fire zone for one riser will be 4832 square meter. So, since our area here in this particular project is 4229 square meter, we will consider one zone and we will have one riser. Similarly, we need to make zoning layout for all floors, and also then we will place the riser locations in each staircase as you can see on your screen. Each staircase will have one riser for landing valve and we will have one sprinkler riser for one zone. So as I already told you, we have only one zone here in this particular building, so we will consider just one sprinkler riser. Once we done with the above, we need to develop the riser schematic diagram. Riser diagrams typically illustrate the vertical arrangement of pipes, valves, fittings and other components, showing how they connect between different floors or levels of a building. As you can see on your screen, this is the enlarged portion of fire pump room extracted from the overall riser schematic diagram, and also you can find enlarged portion of riser so that it is easy for you to look into the complete subject. Apart from that, here in this slide you can see 3 risers, 2 for landing valves and 1 for sprinklers. So in our project we will consider 2 landing valve risers and 1 sprinkler riser. Then we need to perform the hydraulic calculations. By considering the remotest area of sprinkler operation, we will perform the calculations in order to select the fire pumps. The procedure for performing hydraulic calculations has already been explained in our previous videos. You can find the link in the comment section. Anyhow, I will explain the steps to be followed while performing the calculations. So before performing the hydraulic calculations, we need to identify the hydraulic remotest design area. For example, in this particular slide, if the main line is coming from the left side staircase area, then the farthest area will be the remotest design area, that is hatched portion. For example, in this hydraulically remotest design area, if we consider quick response sprinklers because of light hazard occupancy, then the design area will be considered based on nfpa 13 figure 19.3.3.2.3.1 2019 edition. If we consider standard response sprinklers for light hazard areas, we need to consider design area as 1500 square feet and need to follow density area curves as per nfpa 13 figure 19.3.3.1 2019 edition. Then the next step would be, for example, see if the main line is coming from the right side of the staircase, then the farthest area will be the left side, which is shown on your screen. So the remotest design area will be on the left side. The same comments which I explained in our earlier slide will be applicable if we consider this particular area as hydraulically most demanding area. So it is important to finalize the riser locations before we move ahead with the hydraulic calculations. So basically we will look into additional details which are required to perform the hydraulic calculations. On right hand side we have the hatched portion, which is the most hydraulically demanding area, and we have shown a loop piping in this particular project. Apart from that, the main line has been considered from the left side staircase, and also we have shown immediately after the pipe crossing the staircase, we mentioned or we have shown zone control valve. Apart from that, pressure reducing valve might be required if the pressure at this particular location before the zone control valve is more than the system component's rated pressure of 175 psi. Whether we need to use PRV or not will all depends upon hydraulic calculations. Once this pipe routing in the remotest floor, for example in our case it is the 10th floor, has been done and the sprinkler design in the remotest area is done, then we need to take our piping till the pump room. Any route can be followed from the riser shown near the left side staircase shaft. Upon completion of routing, hydraulic calculations will be performed. The pipe sizes mentioned here in this particular slide are tentative and shall be verified based on hydraulic calculations. If you want to know the type of piping arrangements to be considered in the sprinkler system design, please watch my video available on YouTube, and the subject will be wet pipe sprinkler systems. Now we start locating the sprinklers in each room for the entire floor based on hazard classification as described in nfpa 13. For light hazard rooms, we will place the sprinklers with coverage area of 20.9 square meter per sprinkler. The coverage area shall not exceed 12.1 square meter for ordinary hazard group 1 and group 2 occupancies and 9 square meter for extra hazard group 1 and group 2 occupancies. We shall maintain a maximum distance of 4.6 meter between sprinklers for light and ordinary hazard areas and 3.7 meter for extra hazard areas. The minimum distance between sprinklers shall be 1.8 meter on center. The minimum distance from wall to the sprinkler will be 4 inch. Please note, if there are any obstructions like beams or ducts etc., then we need to maintain some distance from the sprinkler to these obstructions as per nfpa 13 requirements. If the ceiling is slope type, then we need to measure the distance along the slope. However, mostly this will be applicable for warehouses since they have sloped ceilings. Coming back to this building, based on the earlier points, we will place the sprinklers in the entire building in this way. Distribute the sprinklers in the entire floor as shown in this drawing. If you want to learn how to place sprinklers, you need to watch my video on fire sprinklers design layout for office. Here you will understand how to place the sprinklers and the coverage area requirements as per NFPA 13. Now we need to draw the pipe routing for the main line and also the loop. So basically here you can see on your screen there are various points mentioned. For example, on left hand side you can find risers for sprinkler piping and landing valves at staircase. On right hand side there is a staircase. You can find landing valve riser 2 and also pressure reducing valve to be provided if required as per the hydraulic calculations. Apart from that, extinguishers have been placed as per NFPA 10 guidelines. Fire hose cabinets should be placed as per NFPA 14 requirements. 1 inch inspector test pipe on the right hand side at the bottom corner. We need to install ITC, inspector test connection, which has to be taken from the remotest sprinkler and to be connected to the drain point in the toilet. Sprinklers shall be used as upright if there is no false ceiling in the building, and if there is any false ceiling like tiles false ceiling or gypsum false ceiling, we need to go ahead with the pendant type sprinklers. We need to show the dimensions or the distance between the sprinklers and distance from the walls in the entire floor, and also zone control valve has to be shown. So all these points has to be covered in one particular floor. And in next slide we are going to draw the branch piping by considering the pipe schedule in order to find out the pipe size based on number of sprinklers. As I already told, we need to draw the branch pipes from the loop piping. So branch piping to be designed with pipe size. Pipe sizing can be considered as per pipe schedule method. However, we need to cross check the pipe sizing with the hydraulic calculations. We need to mention the riser details also in all floors. If you want to know about pipe schedule method, or if you want to know how to design, or if you want to know how to do the pipe sizing for the sprinkler system, you need to watch my video on pipe schedule method as per NFPA 13 requirements. Please note, for pipe schedule systems, for ordinary hazard occupancies, branch lines shall not exceed 8 sprinklers on either side of cross main, and there are certain conditions if you want to increase to 9 to 10 sprinklers on cross main. For hydraulically calculated systems, the pipe size to be considered based on hydraulic calculations performed. So we are almost going to conclude the design, but please note we need to space the sprinklers in the pump room as well as per nfpa 13 requirements. Finally, we need to draw the routing of the pipes from the pump room till the hospital building. In our case, the pipe will travel through the tunnel to reach the hospital. So basically, we have finished our design. Apart from the design, we need to submit installation details and fire pump room layout to the client along with the complete package. If you want to know more about the firefighting installation details and fire pump room pipe sizing and the layout, you need to check my video which is already available on YouTube. If you find my video useful, please make sure to hit the subscription button and also comment in the comment section. This will motivate me to prepare new videos.